This is summer 8.5. We're going to deal with systems of linear equations, a very important part of 8th grade Algebra 1. Solving systems. Systems involves two linear equations. So you have two lines, and they are given in some type of format. These both are given in slope-intercept form. And if we graph those, you get this type of situation. So let's take one instance where you have a line, and then you have another line, another equation, which is represented by a line, and they're going to intersect. Those points are going to intersect. All the green points are solutions to the one equation. The blue points are solutions to the other equation. And so you can get a couple situations that can happen. So you can get, let's make this point a little bit smaller. So you get a point that is on both lines. That means this point right here, this purple point, is a solution to blue, and it's also a solution to green. So that would be the solution to the system. If it was just on the green, it would be true for green, but false for blue, because any point on blue is going to give me a true value for the blue equation. So if it's off of the blue equation, if it's not on the blue equation, means it's not a solution. So if it's off of blue, it's not a solution to blue, but it's on green, so it's a solution to green. So it's only a solution to one of the two equations. This is also a solution to only one of the equation. It's a solution to the blue equation, but not the green equation, because it's not on the green line. If it's on neither of the lines, then it's not a solution to either of the equations. Very important. You can either get one solution, no solution, or you can get a solution to both equations, and that would be the solution to the system. Okay, so very important to understand what are we trying to find. So it's, well, that's two. Let's go with one. So it's in slope-intercept form, and it wants us to solve by graphing. Now, graphing is not the most efficient manner. It's not the best way to solve these systems, but it is pretty simple, but it only works if that solution is on a grid line. And if it's not on a grid line, then we have to estimate, meaning if it doesn't intersect at one of these grid lines. So let's take this equation. Let's make this the blue equation. So the first thing is my y-intercept is going to be 10. And then my slope is going to be up 1, right 2. Now that takes me off of the graph. So I could go down 1, left 2. Down 1, left 2. That just makes it easier. I can see that point on a grid line, and we'll graph this in blue, and we'll connect those dots. We'll improve those connections, and that looks pretty accurate at that point. We'll draw arrows to represent all the solutions, and now we'll graph the second equation, and we'll graph that in green, and my y-intercept is -4, 1, 2, 3, 4. My slope is 4, up 1, 2, 3, 4, right 1, up 1, 2, 3, 4, right 1. And, oh, very interesting. Okay. That's not kind of fun. So that is going to come off of the graph. So there's another reason why graphing is not great. I'm going to extend this out, and I'm going to move that arrow out there. I'm going to draw arrow lines for here. So it looks like my point of intersection is right here. So what is that point? Wow. I'm making a video. Okay, thanks for letting me know. So we can make, now we have to sort of make an approximation. So we could do up 4, right 1, 1, 2, 3, 4, right 1 takes my 1, 2, 3, 4, right 1, 1, 2, 3, 4, right 1. And so that is kind of interesting. 1, 2, 3, 4. Yeah, that's about 4. And this slope is 1/2, so that's up 1, right 2, up 1. Well, that should be 1, should be this same 1. Yeah, so these are off a little bit. So do you think that is? Yeah, you think that's going to be over there? Okay, so let's ungroup. Okay, so that's going to be up 1 apparently, and that's going to be up 1, and then over 2. I mean, is that point? Yeah, I guess it might be. Okay, so what we do is we're looking at this and we're kind of saying, okay, that's the point of intersection. So what's that location? So that location is 1, 2, 3, 4. That looks like 4 in the X, and that's 10, 11, 12. 4, 12. So what we can do is now is we can plug that in and we can check and see, is it a solution to both? So we would take the equation y equals 1/2 x plus 10, and we'll plug in the y value, which is 12. We'll plug in the x value, which is 4, and we got to make sure that that is a true statement. 1/2 of 4 is 2 plus 10, 12 equals 12. So that point, that coordinate, 4, 12, is a solution to the blue equation. So that's good. We like that. So we know that it is a solution to that. Let's take the other equation, y equals 4x minus 4, and let's plug in those values. 12 equals 4 times 4 minus 4. 12 equals 16 minus 4. 12 equals 12. And that is also a solution. So we know that that is correct. So my answer to the system is 412. This is a really good example of really comprehending, what all this means and how to utilize your solution, and how to, when it goes off the graph, how can you still get the answer through graphing? So we graphed, and we would hope that we would have a 20 by 20 grid, and that wouldn't have been a problem. We could have just continued to extend like we did here, but we had to do some approximation. So not an easy problem there. All right, these are in standard form. So standard form, we're going to, system by substitution. So substitution, we're going to isolate one of the variables. So I'm going to take this equation and I'm going to isolate for y by adding 3x. And that gives me y equals 3x plus 2. So I'm going to substitute this value in for the y value in the other equation. So where I see y, I'm going to substitute 3x plus 2. And that equation now becomes negative x plus, instead of saying y, we're going to substitute 3x plus 2 equal minus 4, excuse me. We continue on with the rest of the equation. And now we're going to simplify. So That doesn't change. It's just there's an invisible 1 that gets distributed. So it's negative x plus 3x plus 2 minus 4 equals 0. We're going to simplify. We got like terms here. That's 2x. We have like terms here. That's negative 2 equals 0. We're going to add 2. 2x equals 2. Divide by 2. X equals 1. So that is my x value to my system. Now I can plug it in. I got to find my y value. Which equation is best to use the y value to find my y? Well, I'd use this equation right here. So y equals 3x plus 2. I'm going to substitute the value of 1 in for that. Y equals 3 plus 2. Y equals 5. And I know that my solution to the system is going to be 1, 5. And I can plug both of those in, that value into both of those, and I would expect to get a solution that they both are true, that it's a solution for both equations. Solve the system by elimination. Okay, a little bit different here. So when we eliminate, first of all, they have to be in the same format. This is in slope-intercept form. This is in no form. So we first got to make sure that they're in the same format. So I'm going to put them in, assuming this is not slope-intercept. This is standard form, and this is no form. So I'm going to put them both in standard form by subtracting 2y. Giving me 3x minus 2y equals 6. Now, if I look at my two equations, I have x plus y equals 12, and I have 3x minus 2y equals 6. So they're in the same formats. Their x's are on top of each other, the y's, and their constants. X's and y's are on the left, constant is on the right. But through elimination, that means if we add these columns up, they're going to cancel one of the variables, which it does not. So which variable, I have to decide which variable do I want to cancel. Well, I'm going to cancel the y's. Why did I pick y's? Because my signs are at least opposite of each other. So all I got to do is multiply this equation by 2. I'm making it proportional. So I'm multiplying each of the pieces by 2. When you make it proportionally bigger, you have to multiply every term in the equation. So this equation now is 2x plus 2y equals 24. And I'm going to bring that other equation, 3x minus 2y equals 6. And now notice when we add this column, those y's are going to cancel. That's the elimination part. So I'm going to add that. That makes 5x. These cancel, equaling 30. Divide by 5. X equals 6. So I found my x value, and that's really efficient and nice because I was able to get rid of one of the variables. Now I'm going to take one of these two original equations and I'm going to plug in x6 for x. I'm going to take that top equation, x plus y equals 12. X plus y equals 12. I'm going to substitute the 6 in for x. Subtract 6, I'm solving for y. Y equals 6. So my point is 6, 6. Nice. Worked out quite nicely. Solve the system. So I can use any technique that I want. I can use substitution. I can use elimination. I can use graphing. I'm going to use substitution. And I'm going to isolate this variable. I'm going to add the 2x to both sides. I'm going to minus the 3 from both sides. And that gives me y equals 2x minus 3. And then I'm going to take this equation, and where I see y, I'm going to substitute this value. So that equation now becomes 3x plus 4 times my y value. Well, my y value is 2x minus 3 now equals -1. Do you see why I like this? Is we've turned an equation that has two variables, two different variables, and I can't solve. I can never cancel everything to get a variable or equaling a constant or a number. So what I did in substitution, notice I've gotten rid of my y values and now I'm only in x's. So we're going to distribute that. 3x plus 8x minus 12 equals -1. That's 11x minus 12 equals -1. We'll add 12. We get 11x equals 11. Divide by 11. Gives me a value of 1. So my x value is 1. And now I can substitute that in to this equation because I need to find my y value. 2 times 1 minus 3, y equals 2 minus 3, y equals -1. And I now have my solution to my system. Explain your choice of method. Well, graphing's horrible. It may seem easy, but it's the least accurate. And then I could have moved this and done, well, I wouldn't want to do canceling because then I have to multiply, or elimination, because then nothing naturally cancels when I move this constant over to get it in the same format. So substitution, which was my initial inclination, worked quite nicely. Without graphing or solving, determine whether the system of linear equation has one solution, infinitely many solutions, or no solution. So what we need to understand is when we get infinitely many or no solution, the variables cancel, and you're left with either a true statement or a false number statement. True number statement or a false number statement. And if it has one solution, then the variables don't cancel. Left with one variable. You can solve. You can solve it like the last two questions, examples that we did. So in this situation, if I substitute it in, if I use the substitution and I take this for y and I move it, I'm not going to cancel out. My x's don't cancel. My y's cancel because of substitution, but my x's don't. So I'm going to end up with one solution. You can solve it. That's why. So meaning if I write my statement 4x plus 8 equals 5x plus 1, when I move that 4x, I get a solution. So I'll be able to solve this. So since I can solve it, I know I'm going to get one solution. Without graphing or solving, determine. Yeah, these are going to cancel. Well, without solving, well, you kind of got to solve because you don't know if your number statement is going to be true or false. So if I plug this in for y, I get 2 times x, 8x minus 1 equals 16x minus 2, which is 16x minus 2 equals 16x minus 2 minus 16x. And I get -2 equals -2. That's a true statement. So I'm going to get infinitely many solutions. So I guess we should put that in there. If it's true, it's going to be infinitely many solutions. If it's false, it's no solution. Not order, group, low, group, ungroup. Wow, I didn't mean to do that. It's not going to let me. Okay, let's do this. Let's group, pull that down, and that's all I needed. So if it's true, it's infinitely solutions. If it's false, it's no solution, meaning those two lines do not intersect. So these are actually the same line. Infinitely many solutions are when the lines are the same. So I guess we can go over those situations too. We have a situation where you have two lines, and this is one solution. When you have two lines that are parallel to each other, that is going to be no solution. And that's a false statement. That's a false number statement. And then when you have two lines and they're the same lines, that is infinite many solutions. And this is a true number statement. So, yeah, that's good. So, very important. Explain your reasoning because they're the same lines. Without graphing or solving, determine the weather of the system. So, if we use substitution, you're going to get 6x plus 2 times negative 3x plus 2 equals 10. 6x minus 6x plus 4 equals 10, and you get 4 equals 10, which is a false statement. So it is no solution. They are parallel lines. They have the same slope, but different y-intercepts. So that's one way that we can do it without solving, but you're really solving. I don't know. I'm not a big fan of these questions. These are not the best questions to be sort of asking. Kind of think that they're sort of alluding to something that you can do it without solving, which is not the case. In the diagram, measure of angle 1 is 3 times the measure of angle 2. So that is 3x, this is x, and we know that angle 1 plus angle 2 should equal 180 degrees. And if angle 1 is 3x and angle 2 is x, we get 4x equals 180, divide by 4, and we get x equals 45. So angle 1 is going to be 45 times 3, which is 135. 45 and 135. I think that's correct. Yeah, those are not the cleanest of numbers, those boxes. I don't know how you're supposed to fit 135 degrees and 45 degrees. The price of 2 pears and 6 apples is $14. The price of 3 pears and 9 apples is $21. So we're going to write two equations for this. We're going to write this equation: 2 pears plus 6 apples equals $14. And then we're going to write an equation for this: 3 pears plus 9 apples equals $21. So we can graph it, we can substitute, we can eliminate. I'm going to use elimination, and I'm going to cancel out the p's. So I'm going to multiply the top by -3 and the bottom by 2 and check and see what happens. So -3 times 2p is -6p minus 18a equals negative 42. Remember, we have to multiply by all three terms. And we're going to do this too. That's 6p plus 18a equals 42. This. And now we're going to add the columns. You get 0, you get 0, you get 0. So the variables canceled. So I know it's either going to be no solution, it's either going to be parallel or the same line. And then I have a number statement that is true. So can you determine the unit price for pears and apples? They're the same unit price. So I think the answer is going to be no. You can't find the unit price because you've got two different variables and you can't solve for pears. Even though they're the same proportion, they're the same unit price. That's all we know is that they are the same, but we can't tell what they are exactly. So, tricky question. A bouquet of lilies and tulips has 12 flowers. Lilies cost $3 each. Tulips cost $2 each. The bouquet costs $32. Write and solve the system. All right, so we have lilies, L plus T equals 12. L and T, L equals the number of lilies, and T equals the number of tulips. So number of lilies plus the number of tulips should equal 12 total flowers. Now we're going to take, that was this equation. Let's write that in blue. I'm sorry. So this information we're taking, and that's L plus T equals 12. And then we're going to take this equation and with this piece of information. So if each lily costs $3, so 3 times the number of lilies plus $2 times the number of tulips should equal the total cost. And that's how we create two equations to create a system. We can use elimination or we can use substitution. I'll use substitution. We'll solve for L by minusing T. So L equals negative T plus 12. And now where we see L, we'll substitute. So we get 3 instead of L, we'll do negative T plus 12 plus 2T equals 32. Negative 3T plus 36 plus 2T equals 32. Combine like terms, that's negative T plus 36 equals 32. Let's minus the 36. Negative T equals negative 4. Divide by negative 1. Divide by negative 1. I have 4 tulips. There are 4 tulips. And then if I want to find lilies, I can go back up here. And lilies equals minus the number of tulips. So lilies equals 8. And we have 8 lilies. Does 8 plus 4 equal 12? Yes. And if you plug them all back into the other equation, you'll get that it works. So, all right, good question. That is definitely a problem that you will see quite often. How much does it cost for 2 specials and 2 glasses of milk? So, same thing. We're going to write an equation. For this guest check, we'll say 4 specials plus 2 milks equals $28. And then we'll write an equation for this. 3 specials plus 4 milks equals $26.25. Don't like that decimal. Let's multiply the top by negative 2. I'm going to cancel the m's. So that will give me negative 8s minus 4m equals negative 56. So this equation now became that. Here are my 2 equations. This is actually the new blue equation. And if we add the columns, you get negative 5s. These cancels equals. And then you got 26.25 and 56. That's going to be what? 30.25? Is that right? No, I had to borrow. 56. It's going to be 19. Yuck. 56 minus 26.25. 29.75. So 29.75. And it's negative. That's negative because we have more negatives than positives. Probably a lot of students make a mistake there. We're going to divide by 5, negative 5. S equals, that goes in 5 times, and 47 goes in 9 times. And 45, that's 25. 595. Did I do that correctly? Let's divide this by 5, and we get 595. Good. All right, so a special costs $5.95. How much does 2 specials and 2 glasses of milk? So that's how much one special costs. And now we can plug it back into one of these. There's a lot of work we got to do here. So let's take that equation. Let's make it in blue. 4s plus 2m equals $28. Let's put the s in there. So 4 times 5.95 plus 2m equals 28. 5.95 times 4. So times 4 gives us 2380. 2380 plus 2m equals 28. That's minus 23.8 minus 23.8. 2m, 2 milks equals, that's going to be 2, borrow. That's going to be 4. So $4.20 divided by 2. So each milk costs $2.10. $2.10. The specials cost $5.95. So now it wants 2 milks and 2 specials. So 2 times the milk, which is $2.10, plus 2 times the specials, which is $5.95. So that gives us $4.20. This gives us $11.90. Yeah, $11.90, right? $5.95. I think it's $11.90. $5.95 times 2, $11.90. And then we're going to add those together. And that gives us 1. That gives us $16.10. Notice I didn't write 16.1. You need to make it a currency. Make sure that it makes sense. And you have your dollar signs, which they added in there, which I don't like. They're giving you too much credit that you'd remember the dollar sign. And you have to go out to the penny. So you have to go out to the hundredths. You can't write a dollar sign 16.1. So that would be the total cost for 2 specials and 2 glasses of milk. All right. Those are good questions today. Enjoy.